Okay, for people joining this live stream, we are looking at functions that have been considered experimental in earlier versions of Wolfram Language, and we are exploring what we can do to bring them out of experimental status and make them permanent commitments in the language. Okay, first section here is about geographics. Well, I like dynamic geographics. The only thing that I'd like to comment, there was some feature that I was thinking was not there.
The ability to switch to satellite view?
Yes. And also the messaging, excuse me, when you go too close in satellite view, where, you know, there is some mode. I mean, we just can't have people have close satellite view with our, integrated services providers, okay? Without them subscribing to that. Am I making sense? I mean, we can deliver that stuff. We just can't deliver it. We can't have them generate millions of tiles there.
Right.
But I don't think there's a problem. I mean, what's the status of dynamic image?
I think I don't think anybody from that is in this meeting.
Okay. Okay, does anybody object to de-experimentalizing dynamic geographics? Oh, just have one quick look at the design.
I mean, the design is basically the same as Geographics.
Okay. And I can resize this thing, right?
Mm-hmm.
I think this is pretty nice. We just have to get it integrated into Wolfram Alpha now. Okay, fine.
But presumably that should be easier now that we have the cloud version.
Absolutely. And now that we have the new containerization, the new front end for Wolfram Alpha.
Mm-hmm.
Okay. All right. I think this is good. All right. Onward we go. I'm good with this.
Okay. Raj, is there anything else for me?
Nope. Thanks.
Okay. See ya.
Yep.
What about the other ones in the same family? Oh wow, why is that not experimental? And for some reason, augmented doesn't point to snub. It's been snubbed. The snub polyhedron has been snubbed. Never mind. Can somebody say why does augmented not point to snub, and why was snub experimental in the first place?
Well, when we went to the whole full review of those group of operation on polyhedron, I think it was just at the end that you felt like snub was not the right one. There was no precise reason. So you say, well, let's just put it experimental for the time being.
Well, let's talk about it. Why? I hate this takes the same options as. We really have to get these, so you don't have to go look at another page, right? Okay. What did I say about snub polyhedron when we were first looking at this? What was my reason? And also, could you explain the reason why augmented doesn't point to snub?
Oh, that's probably a documentation mistake we'll fix.
Okay, fine. All right, but so explain to me why I didn't like this. Do you remember?
No, not really. I guess maybe there was an example you couldn't reproduce or such a thing, but there was.
Okay, well, let's take a look at this creature. So, I mean, the most famous creature is the snub cube. Okay. Is that right? That doesn't look right to me. No, look at it. It's not right.
So try polyhedron data of snub cube.
Oh, come on. Come on. Why does that not work?
Entity are not supported in graphics. You should probably add the polyhedron property of it.
Bluff. Come on, we can do this. That seems like something we should make work. Make sense? Okay, what's the story here? Is anybody going to respond? I mean, so
I have no idea. I mean,
yeah, so let's make it work. Okay, what is going on here? Come on, what's happening?
snub cube is an entity. We don't support entity.
Well, then you should, because it's got to actually interoperate. You can't just be adding random new things to the system without having them connect with other stuff.
But we don't support entity in all over the system. That's the whole thing.
Oh, but we should be supporting it wherever we can, and this is an example of a place where we can, and we should do it.
Okay, we will do it. I mean, we did that for graph. It takes some time and some effort, so we'll do it.
Yeah, well, I understand, but that's what we should have happen. I mean, okay. Now, explain to me why this snub cube, right? See that snub cube? See how regular it is? Okay, this is what was wrong. This is what happened last time, right? Explain to me why this snub cube is all smooshed and irregular while this snub cube is not.
Right, so what we essentially return, it's a topologically equivalent polyhedron. So you can always change.
Yeah, I understand that, but this is doing geometry. So why is it that this snub cube is not the same as this snub cube?
So essentially the coordinate, we pick the coordinate based on this internal set of parameters, right? So, but we are sure that a snub cube are topologically equivalent. We cannot guarantee that they are geometrically equivalent.
Okay, so explain, because clearly in this case, there is a set of parameters which would make them geometrically equivalent. How are we picking the parameters for snubbing?
We pick a global one. Otherwise, we need to run an algorithm for every single one, which is unrealistic.
Okay, who else? Is Roger here? Who else can comment on this?
Yeah, I'm here.
Okay, so can you comment on this? This seems wrong, and this is, I remember now, and I wish we had enough notes that from the previous design review of why we experimentalized, and that's something we should keep in future. You understand? If the thing, if there's a reason why it was experimentalized, right? Like that we couldn't resolve this. Do we have any place for keeping that information?
I think that should go in the reference page, though. If there's a comment like that, we should capture it on the reference page. Otherwise, I don't know where it would go.
Well, no, I don't see a problem with that. I don't necessarily think it's appropriate for users because it might be just we ran out of time in this version and things, Which...
No. But it shouldn't be. So an excluded note that says.
Okay, but I think we should put it in a standard place on the source of the reference page. Otherwise, we'll never notice it in a discussion like this.
Mm-hmm.
In other words, we should have, so Raj, I think that would be.
That's probably a good idea, actually, because that gives us a more flowy.
Yeah, I mean, it means that in this meeting we're capturing those, exactly that section, and Raj could automatically harvest that for these meetings.
Right, as long as it is in a certain cell context.
Yeah. So we need to create that cell then.
Yeah, I think design discussion would be a reasonable place to put it. You could just harvest.
Usually that's filled with all kinds of other things.
Okay, fine. Well then, fine.
I mean, it does seem right, but it's usually filled with all kinds of other things.
Okay, well, why don't we put it, because I think it could be a more generic thing. It's like future discussion or something. Because it could be something where when you come back to review this function, it isn't experimental, but there's still something about it that wasn't finished or should be extended, so to speak.
It's usually what's in there.
What's in where? In design discussion?
Yeah.
Okay. All right, we'll come up with a name for this, but I would recommend something which doesn't become vestigial just because it got de-experimentalized. Does that make sense?
Yeah.
Because I mean, I think it's worthwhile. There's no problem if we over-harvest. If we've got something that's experimental and it has a future discussion, then we harvest the future discussion for the de-experimentalization discussion. All right. Now, explain. So there's some geometry you need to explain here. Okay. Is it the case that when we augment,
you need to basically say, you need to say. So there's a neighborhood information that tells you what's nearby, right? Because you're snubbing corners, you're truncating corners. The question is how much you're going to truncate them.
So is it the case that there is so if I make myself a nice by the way, we've got some background noise. Somebody might want to adjust something. So if I do this, okay, so that's, I don't understand why that's 0 snubbing. Okay, I see. So there's some snubbery. Wow, that's really funky.
Well, one additional thing with some of these polyhedral operations, when they work on non-convex things, they don't,
I understand, but this is a perfectly happily convex creature. So let me just understand something. In the case of augmented polyhedron, is there a similar issue? I don't think so. It's unique, isn't it?
No, I think it's a similar issue there.
Ugh.
What issue are you talking about? I mean,
I want to know. Okay, so
the question is, how big do you want to augment it?
Oh yeah, but there's no
we have a
problem with
parameter.
augmenting it. No, but there's no irregularity. So here, the symmetry. Look, here's the problem that I'm having. The symmetry of the cube is preserved in this augmentation, right?
Right.
Okay. The problem that I'm having here is in the snubbing, the symmetry of the cube is not preserved, right? In the official snub cube here, the symmetry of the cube is preserved, if I'm not mistaken. Is that correct? That the symmetry of the cube is preserved in this snubbing?
What kind of symmetry? I mean,
rotational symmetry. I mean, all symmetry operations. The group of the cube is also a symmetry of the snub cube. True or not true? I think it is. So that's the problem that I'm having with this snubbing. For some reason, and I don't really understand why, snubbing is not. So why do when I have.
So if is that the case, it's just an implementation issue. We'll fix. We'll make sure to preserve the symmetry group and those stuff. So, I mean,
fine, but I mean, I'm trying to understand why that's not happening. So another question: this parameter, when it's 0, why isn't that just an ordinary cube? And by the way, you haven't documented the second argument of snub polyhedron,
right?
Which is wrong, right?
Yes.
Yeah?
Yes.
Okay. But okay, let me look at augmented now for a second. Okay, so there you have said how to augment it. Okay, I am just confused here. Help me out. Why is the 0 case not just a cube with nothing snubbed off?
It's a bug. It's a corner case. It's a bug we are going to fix.
But what do you mean it's a corner case? Why is it not a limit as r goes to 0?
Because the way we actually compute it, I mean, the way we generate the snub polyhedron is a combination of a sequence of operations. So it may happen that in that corner case, it doesn't work that way.
I don't understand this working thing, because I don't understand. Why isn't this a conceptually straightforward operation? You go to every corner, and what does it mean? Is there some strangeness in the definition? You go to every corner, and then what do? You look at every edge, and you shorten every edge by some fraction. Is that correct, or is that not correct?
Conceptually, that's the way, but implementally, that cannot be the way. So that's the whole problem. Because it just doesn't work that way. I mean, to implement it will be extremely slow. You don't get the
right. Okay. So you need to do some more work on this, basically. I mean, as far as I'm concerned, if it and we should make some comment about this when it's. I mean, yeah, it looks to me like it's just buggy right now because it just shouldn't break the symmetry. Just doesn't make any sense for it to break the symmetry. See what I'm saying?
Sure, if it's that way, that's not a problem. We can
No,
fix
no,
that.
no. But why would you ever even think it could make sense for it to break the symmetry? I'm very confused. By the way, somebody is making a lot of background noise. I don't know who that is, but really good if you put yourself on mute.
No, my key point is the following: is that when we define a snob polyhedron for any arbitrary polyhedron, there is no preservation of symmetry involved. The snob of a
understand that.
polyhedron is the beveling and the truncation. And those truncation and beveling, in principle, have parameter which doesn't allow you to always guarantee that symmetry, that you preserve the symmetry. So we implemented that general operation. Right? So we can make sure that when you manipulate a cube, the basic cube, we return you one where.
But I don't understand. Given the description of the operation of, you just go to every corner, you shorten every edge, right? I don't understand.
When you shorten, is that that length have to be specified.
Yeah.
Right? And the length vary, and it's a fraction, and depending on the actual geometric object, you cannot guarantee that you preserve the whole same symmetry.
No, I understand that, but I don't understand. Well, actually, I don't understand in the case of the cube how any length, yes, clearly you can change the length, right? But I don't understand. Okay, so roughly there, it seems roughly symmetric. Now, as you go further, I just don't understand how it's losing its symmetry. I don't understand how. I think there's a bug. I think there's a math mistake here.
Yes, and that one will take care of it.
Okay, fine. Why don't you explore this? Because I am pretty certain that there has to be something wrong that's causing it to break the symmetry here.
Sure.
Okay. All right. Let us return to this question later. Okay. On to the next item. Okay.
So here we have two functions, subset map and carry.
Subset map is starting to have its day in the sun with quantum computing, which was the original reason. Yeah, I mean, I am pretty happy with subset map. It seems like it's been pretty natural. Do you agree?
Yes, I think the design of this function is clear, modulo some extensions of the third argument.
Which is also the second argument in the curried form.
Right.
What are those extensions?
We have discussed other times notations for columns, things like that.
Okay. Well, I don't have a problem with de-experimentalizing this guy. And I think its name has proved okay. Do you agree?
I think so. I haven't seen any complaint in that regard.
I mean, I sort of can remember what it does based on its name, which is always good. Okay, let's go on. Curry. So we had a thing recently. What was the function we were just looking at recently?
Yes, so that was last week. We were looking at ordering in relation to Carlos' ascending and descending orderings.
Yes.
And we wanted to have the basic form here called reversed. And actually, Roman has suggested something similar. So Roman's point was that carry is doing simultaneously two things: the carrying of one argument functions and the reordering of the first two.
Yeah, so maybe we should get rid of the reordering idea and put that in this reversed function.
Yes, so he suggests that the default case should be the equivalent of carry 2, not carry reversing the first two arguments.
Okay, so carry 2 would do what? Let me look at this for a second.
Yeah. So carry 2 is taking one argument at a time, but in the same order. Carry of f, 2. Right. While the default carry f will reverse.
I don't understand why the default is not something. I mean, it's kind of useless, but I mean, the curry 1 would just do this, right?
Right.
It's no op.
Right.
So curry 2.
So it's taking the arguments in the same order. If we don't have the second argument of curry, if it's just curry F, it will reverse the order. And our argument a few months ago was that that's the most frequent case in our operator forms.
Yeah. Does this work?
Well, it's going to be waiting there for an infinite number of arguments, so effectively it doesn't work.
Well, what did it just do?
Well, we just merged the arguments. So the idea of curry is that it doesn't matter how you pass the arguments in any group of arguments. It's there just waiting for the right number of arguments.
By the way, Ethan on our live stream is commenting on polyhedra and complaining that we don't support refraction and shadows and reflections. We have a project to do, I mean, more advanced shader type stuff. Maybe the group of people here is wrong. Maybe Roger can comment on that.
There's no active project right now. There's been discussions going back for a long time. We will do shaders. We'll do quite a bit of shaders in 12.1, not yet covering shadows and things like that. But
you know, it's funny. I mean, back in the early 1990s, we were going to do that, and it just turned out people didn't care enough.
Yeah, I think that. Well, not to get on a side note here, but even Leonardo da Vinci lived soft shadows. We can hardly do that today. So it's there's no current project, but we'll you know, I think that as we get warmed up in doing more shader work, I think shadows.
What is the best path for somebody who actually wants to do that? So they create all the stuff with our nice new polyhedron things, and then they want to do a photorealistic rendering. What's the best path these days for exporting to what? To Maya? To something else? What do you export to?
It depends on. I mean, you can export to Povray. You can export to. I don't know that Maya does shadows either.
Are there? I'm just curious. Are there like free products that like do shadows and things?
There is RenderMan. You can essentially use RenderMan, which is free for non-commercial to do that.
I see. And do we? Interesting. Do we have a workflow describing how to do that? I mean, do we have an export to RenderMan? What is the RenderMan format?
Right, we have we supported that a while ago. I think there is an old format.
Oh, really? Yeah.
Yep.
Well, one thing to remember with shadows, it's like transparency. It's a global operation.
Yeah.
So.
No, it's obviously very complicated, right?
Yeah. Games are clearly very interested in doing that, but they, of course, have performance constraints. So there's like an endless set of methods how to get decent shadows and still be performant.
Right. It would be nice if we gave a workflow, if we had a workflow that we could reference on these pages that told people how to go from our graphics to something that is fully photorealistic using some, easily available external system. If we know the answer to how to do it, we should get a workflow that says it. Does that make sense?
Sure.
Charles, is that something you can? I mean, probably somebody in our art department knows. You know, if nobody else knows a reasonable way to do this.
Sure, there are several workflows. We even experimented with RenderMan, so that shouldn't be a problem.
Okay. Okay, a couple of comments on the live stream here that are interesting. Ethan is saying subset maps should work on numeric arrays without having to decompress them. Interesting comment. Who would like to? Does it work on packed arrays internally?
Yes, packet array it does. Numeric array, I guess it's being extended throughout the system. We will get there soon.
Okay. Sander comments that the wiki article about snub cubes talks about it being a chiral polyhedron with two distinct forms, which are enantiomorphs of each other. Okay, so there's clearly a complicated story here. I think this is a Charles gets to investigate what's going on here.
Well, actually, if you try snub polyhedron of a half 1/3, there is a third argument which we didn't want to document. We'll give you the symmetry. I think that's the whole.
Oh, for goodness sake. So, okay, so it's the, well, you didn't even document the second argument, so I don't know what any of these things do. So you're saying
Well,
that
both of them have fractions, so you could imagine that you specify both beveling and the truncating.
Truncation, right. So,
oh, the second one is some truncation thing. Okay, so
Yes.
there exists a, wow. Okay, so somewhere in this space, there's the symmetric. All right, this requires more math thinking. Okay, let's come back to the, let's see, we were talking about curry, right?
Yes, and now we have Roman with us.
Okay.
Hello.
Hi.
Yes, so we were discussing the default of curry, and I was saying that you were suggesting, Roman, to have the default ordering
Yeah,
rather
two.
than
Yeah,
reverse ordering.
basically be 1-2 rather than 2-1. Okay,
Right.
how serious are we about reversed?
Well, I think that's going to be useful for some cases like the order situation we were discussing with Carlo the other day. The other thing that Roman has pointed out is that is whether we want this function to be carried as well. So the design we were thinking for reversed was that it would take always 2 brackets, and the second one is any number of arguments, and it would reverse all of them.
Yeah, I understand.
But if we want to carry it so that it takes 1 argument at a time as well, then we can only do that for 2 arguments. The alternative is to do carry of reversed of f.
Which would be the operator form, right? Which the current curry of f with the current default gives, which I don't think is very obvious as a default.
No, it's not. I mean, I do think
shouldn't-
that reversed is a better idea.
Yes, I mean, curry is useful and operator forms are useful, but we shouldn't call it curry if it's not.
Well, I don't think we want either to force users to use combinations of carry and reverse continuously.
Okay, let's look at, okay, let me understand the situation here. Okay, so first question is reversed. So remind me again, you know, what we're doing here, you know, we could have something. Do you have the implementation of reversed? Could you just send it to me? It's one-liner.
Yes.
I mean, that would work, right?
Right.
Is there any issue with holding with reversed? You know, I mean, clearly, if you have a hold all function, it's not clear that the reversed function should, in a perfect world, inherit that holding. Does holding with curry? Does holding work?
No, with carry we cannot propagate the attributes.
But I bet we could with reversed if we didn't curry it. And that might be quite useful with things like set. Okay, so the issue is, what if we wanted to have a curried form of this thing here, right? And so what you're saying is, boy, okay, thank you.
Yes, curry of reversed of f. That is the thing that will build these operator forms where it swallows the second argument and freezes it as the first.
That is a very simple implementation. Okay, so then this becomes this, right? We're all happy there.
Right.
This becomes this. Okay, so now you're saying curry of reversed of f, and now that curry, if we defaulted the curry to be the comma 2 curry there, then that would be, then we will get curry of x, f of xy there. Oops, that's not what I want anyway. That's not the curry case. This is the curry.
Y of x, yes. Yes, that builds our operator forms.
Right, and if I were to do this, then that will do that. And if I were to do curry comma 3, that does that, which is right. Do you think reversed is going to need an arbitrary permutation?
I don't think so. I think the complicated cases should be handled by curry if needed.
Because it has a permutation in it.
Right. I do think we need the permutation in curry because there are some operator forms like mapat, which is rather complicated.
Yes.
Because it carries the first and the third argument. And so users may want to carry complicated things with arbitrary.
All right, listen, let's do the following. Let's get reversed in the system and make sure that that shakes down. And let's plan tentatively to dedocument. Well, the question is whether we change curry of f when we change curry of f.
Yeah, I would suggest curry of f should do what everybody expects curry of f to do,
which is a single level curry of x of y.
Oh,
right?
Yes. So the default argument, second argument, should be 2.
So explain that to me. I mean, when I think of currying, I think of it going all the way, not just 2 levels.
Well, what is all the way? I mean, the problem is our functions, you don't see how many arguments they have. I mean, in the theoretical, the way curry was developed, it was always in typed languages where you always knew how many arguments a function would take, and that would always be a fixed number of arguments. And so, because our functions can have any number of arguments, we need that second argument of curry to tell it how many to swallow.
I just wonder if there's a default that can depend on f.
How would you know?
If it's a system function, you might be able to know. It's kind of hokey.
I mean, many functions even have optional arguments, and
sure.
So,
but to me, the curry, taking it to be 2 by default just seems very arbitrary. I mean, is there a more obvious? Is there a more, to me, swallowing everything would make more sense for the default than swallowing 2.
Mm-hmm.
But everything is well defined. You don't know how many pairs of brackets are coming later when you are looking at the first one.
So what? Don't you get? Isn't this a sub-value thing?
Yes, but the head will evaluate before the whole expression. So the sub-value with the first pair of brackets will fire before having the opportunity of looking at other pairs of brackets.
I mean, it will never be able to evaluate because there's always one more to come.
Why is there always one more? I mean, why isn't it? I don't understand. If this doesn't the tree, this is a subtree, right? This is a subtree of a certain shape, and you are ascending out of that subtree after you finish finish with the sub-bracketings, if I'm not mistaken. In other words, if I were to say, look, if I were to take this, and then I were to say G of that, comma, U or something, that is a different subtree.
Yes, but the head carry f2x is going to evaluate on its own before anything else in y and z.
Why? Why is it going to evaluate before anything else?
Because that's how the evaluator works. I mean, doing what you suggest would require a change in the evaluator. It's not implementable as it is right now.
Okay, let me understand that. But I mean, to me, what I'm suggesting makes the most sense for curry of one argument to mean. See what I'm saying? It's the most natural thing for it to mean. There is a subtree, there is a left subtree, and this says, you know, basically excavate the whole left subtree.
But the main use of curry is to have incomplete versions. So you would say something like G equals curry of f comma 2 of x. But then G applied to y would fire, but not on its own.
I understand. I understand. That's all good. But then you're giving that explicit 2. What I'm addressing is what is the default when the 2 is missing? And
I mean, it could
your
never,
point is that go ahead.
Never apply f. Would never get out of it.
Okay, so your question is when does it fire? How does it know it's complete?
Right. Because in an expression, it will try to evaluate the head first, which is itself an expression with brackets. And so it will evaluate that before evaluating the result on the pair of brackets, on the initial pair of brackets. And so we would have to tell somehow the evaluator, we are in a special situation, so don't do the standard thing. And
I mean, the other thing we could obviously have, which is a completely different kind of thing, is a terminator. Right? You could say, if you ever are fed this, then you want to digest it type thing. You get what I'm saying? So in other words, if instead of Z, you were fed a terminator there. I'm sure there's some place where people have used combinators and they've built whole giant, zoos of weird combinator animals, combinator birds.
Yes, but there's never an ambiguity of the number of arguments before a rule fires.
Because any given combinator has a fixed number of arguments, is that right?
Well, it has a certain number of patterns that simplify, and these patterns do not have double blanks or stuff like that. And
right.
I mean, you could say yes. I mean, for example, S only fires if it has at least 3 arguments, and K fires when it has 2. And so there's never an ambiguity there.
No, I understand that. Okay, so listen, here's what I'm thinking. I'm thinking we should de-document the one argument form of curry and basically have it not evaluate. Because I don't think we know what it should do. I think this 2 thing is really arbitrary. I mean,
binary functions are quite, I mean, they are the majority of stuff like is 2 argument functions. I mean, all the arithmetic, all the mathematics.
The previous case was more natural because in most of our operator forms, we switch. We flip the first 2 arguments. So
yeah.
Very natural.
When would we use the curry, the unflipped curry?
We have a few cases like map or apply. So it's conceivable that users have similar functions, but it will be much less frequent.
Okay, so the flipped curry is now achieved how? By reversed, which chooses to curry, is that right?
Right.
How can reversed curry and not have run into the same issue about not knowing how many arguments it's got to have? Because you're saying reversed of f by default eats what? What does it eat?
Well, we can make reversed to carry just one thing. We cannot make it carry more. I mean, we have to, with reversed, we have 2 main choices. Either we make the second argument take many arguments, or we make it carry arguments like carry. I prefer the first case. I think it's going to be more useful.
So sorry, say it again. The first case.
Yeah, the first case is like reversed of what I programmed there. That the second argument take any number of arguments.
Sorry, say that again. I'm sorry. Sorry, I was got
Yes.
distracted. Yeah, go ahead. What were you saying?
So there in the implementation in this one-liner there, reversed of f, it takes any number of arguments in the second pair of brackets. I think that's useful.
That's fine. But so what's your curried proposal? Your proposal is that if it has that you have an additional form which says reversed
of f bracket x bracket y. So that would
no, I think that's args1 blank blank comma args2.
Yes, but args1 would be only one. Args2.
Why is it only one? But why?
Because we want to distinguish from the first case. The first case should fire only when args is 2 at least.
Oh my God, what a mess. Yeah, I get it. That's a mess.
Exactly. So I think we shouldn't try to implement both because it would be a mess. But we have these two options. Do we go with the first type of thing or the second type of thing you wrote?
I think we should definitely support the first thing.
The first one, yeah, I do prefer the first one.
Right, and I think this is, again, mixing the roles of curry and reversed.
Right, exactly.
Okay, so then in order to get the functionality that we currently have for curry of f, what would we have to do?
It would have to be curry of reversed of f.
Why are we putting ourselves through this? Why don't
919, yes.
Yeah, why don't we just leave it the way it is? I mean, in other words, that's kind of ugly. You're right that the curry reversing curry is a little weird, but it is the more useful thing than a pure curry of 2, isn't it?
Yeah, but it shouldn't be called curry. I mean, it's.
Oh, for goodness sake!
I mean, once we have a permutation in the second argument, I think having a permutation as default is not so bad, and it's like transpose, for example.
Yeah, which has 2-1 as its default permutation.
Right.
I mean, the point, Roman, is that, as you're saying, I mean, so given that we have a permuting curry, if you can come up with another name for curry, please suggest it. We spent like an hour just talking about that one name. And eventually we decided that every name we could come up with was more obscure than just saying curry.
Yes, I mean, we could go back to our standard way of naming things, and that is by the person who invented them. And in fact, the one we are looking at, the curry that permutes the arguments, is called curry's C, the C combinator, which was also described by Curry. So it would be curry C, would be the kind of non-obvious name.
Okay. And what are we going to do? Schoenfinkel S?
Well, yeah, we should, but I mean, we cannot use S and K by themselves, right? But
I think we have a package where they're called combinator S, combinator K.
Yeah, that's. But I mean, everywhere else we actually use the name of the people who described them. So why we shouldn't do the same here?
Well, but I don't understand. No, that's completely obscure. So, for example, I faintly knew that there was a curry, that there was a C combinator, but only faintly. And I'm a pretty serious combinator enthusiast, as combinator enthusiasts go. I don't buy that argument. I don't buy the argument that I mean, to me, the fact that our default curry is curry of f, 2 really useful as a default?
I mean, for example, if I need to manufacture a function that adds 1 to its argument, I would say add 1 equals curry of plus, 2 of 1. I mean, for me, curried forms are most useful if they are not yet complete.
I agree. That's fine. But notice that you're happily putting that 2 in there.
Well, now I have to, yes. Of course. I mean, I agree that 2 is a bit arbitrary, but then maybe it's better to not have a default second argument, as you said.
Yeah, but the point is that this operation of flipping,
Mhm.
is clearly useful, particularly in our language. We use it, we use it a bunch. I personally, I'm not horrified.
Mhm.
After this discussion, given that I don't think we should curry reversed, I think it's a mistake to curry reversed. I think reversed is just essentially a functional operator form that does not also have currying in it. I mean, I don't know why, by the way, the only reason that we don't have combinator S, combinator K, and so on, I mean, obviously they're totally trivial to put in there. And I think the reason that we don't have them is we had a whole issue about, right, what we wanted to do was to let people be able to type combinator strings just like they can type, so that I can type, something quotes KS, KS, whatever it is, right?
Yes, but I mean, if we are serious about that, we would need a left associative binary operator without any meaning, right? I mean, but with a nice symbol.
No, but I mean, this, if I'm not
This
mistaken,
is a string. I mean, yes. I mean,
no, I know that. But we could say what we did was, combinator. If we did something like combinator of this turns into combinator K of S of whatever it is, right?
But with our right associative brackets, it just doesn't look very nice. I mean, don't we have a symbol we could use as a left associative binary operator?
Isn't at star? Wait a minute. Isn't at star?
No, that's composition, right? That's not.
So you want something? Okay. So the issue, I was literally just writing about this in this weird detective story about this note in this Turing book about the left associativity convention, which I hadn't really internalized properly. But
I mean, it would have to be binary, so it would apply. It couldn't be flat, right? I mean, that would be.
No, obviously that won't work. But as I recall, so let me look at a random combinator expression. I think I had some big long combinator expressions someplace here. Okay, now that has brackets in it.
Yeah, I mean, that's just unreadable, right? I mean, that's.
Right, but you're saying that this can be bracketless if you do left associativity, is that correct?
I mean, you will still use parentheses for grouping, but a lot less than you need those brackets.
I wish why doesn't that do? There's a good unreadable one. Okay, so what are you saying here? You're saying I have this, which is arguably a bit of a mess, and you're saying if I were to use a left associative operator, why does that give me fewer? So wait a minute. How can I use just parentheses with a left associative operator? Do we have? Okay, we have a lot of operators that don't mean anything. Do we have any of them being left associative? I mean, I'm just amazed.
I don't know.
All this years this hasn't come up because we okay, so something like circle dot. Is it flat? It does appear to be flat. But you're saying that of all of these things, of all of these operators, we don't have any left associative one. It seems very hard to believe.
Yeah, I mean, we have plenty of characters available, right? We should use a nice one and just put in the parsing rules. That's really all that is required. Parsing and formatting.
Well, why don't you take it upon yourself to pick an operator?
Okay.
That isn't, preferably that isn't doesn't already have some meaning. I mean, it would be
Mhm.
good. I was looking at this thing of Turing's where he has some it wasn't helped by the typesetting that was done, but it absolutely, truly atrocious notation where he's got things that look like primes, meaning a pre-operator.
Mm.
It needs to be some kind of dot-like thing, I would think.
Yes, and not confused with any dot that has a meaning, right?
Well, clearly one thing, if it was a semicircle pointed in which direction, if it was if the way it looked was a does this make any sense? So if it's a left associative operator, that means that S dot A dot B dot C is equivalent to A dot B
Yes,
dot C, right?
yes.
And so is there a way, if you were going to write that operator as something which has a certain binding?
Mm. The convention is to leave out these parentheses. So, and you would only put parentheses if we wanted something like A dot parentheses B dot C. And that's why you have a lot fewer of these.
I don't understand why that gives you fewer. I don't see why it isn't a symmetrical problem.
No. The way they are built up is that they're mostly, you see the whole initial segment there is left associative, so that those brackets would simply go away. So.
Okay, so what you're saying here is that if I were to take, there is a way of doing, what is it called? It's called Infix, right? So this thing here has function application.
Mm-hmm.
How would I rewrite this? So this allows left associative. Okay, so if I say infix of, let's say, just f of ABC, comma, let's say 100, comma left. What is that doing? That's, I see. No, what I want to do is f of A.
You need the H, you need the head. This additional argument there. The dot.
Okay. So then this one, so you're saying I go head there.
No, you have one too many. Okay.
No, precedence grouping.
Yes, but the expo has to be flat, I assume.
Okay. So you're saying this. Oh, I'm confused. No, this is no. This would be something like that. What is going on? Let's try the basic example here. Okay, I'm officially confused. Why are those things not working? Precedence and grouping doesn't appear to work.
Nobody's ever used those.
It can't be the case. Well, okay. Look, Roman, could you take it upon yourself?
Yes.
Try and figure out, try and unscramble this, and you can take this very example and show what it looks like in the case where you're using.
Okay, can you mail me that notebook, please?
Yeah, well, I'll just mail you this combinator.
But cannot
also the infix stuff below.
Oh, yeah, okay.
Yeah.
Can we do this with at and parentheses only? Isn't at enough?
Well, what does that? Okay, hold on. Let me look at something here. Let me just send this to Rowan. You're saying A at B at C.
Yes, and perhaps we have that in parentheses and then add something else.
Why does that need to be in parentheses? Because you're saying
sometimes we need to take this as a whole function applied to something else. Exactly.
And you're saying that's the left associative. That forces. I'm so confused here.
Well,
Is that associative, or that is? There's no associate. No, I'm very confused.
this is not about associativity. It's just a notation which implements.
But it is about associativity because A at B at C associates, computes B of C. It's right associative. It computes B at C before it does A at that. You see what I'm saying?
I see.
No, it's
right associative. It goes, look, A at B at C is equivalent to A at B at C, right? Which is not equivalent to A at B at C, right?
Right.
We are out of time, but I'd just like to take a look. Okay, so Roman, could you take a look at this and just see if you can figure
yes,
out
I will.
for this? And I do think we should finally introduce these combinators, and I think named combinators are a fine thing to have. Okay, this is going to be a more complicated discussion. Oh boy. Are you confident that the whole persistence structure is working?
Yeah, I'm confident about persistence. I still have some reservations about initialization, so I'm probably overconfident there. I mean, the thing works, but I mean, we still need a few auxiliary support stuff like browsers for initializations, because it's very bad if you have an initialization persistent stuff that you don't know about and that gets in the way. And so persistence is okay, initialization.
We're going to have to come back to this in a different meeting, but I just want to comment for Christian's benefit, since he's been patiently waiting here. I would like to consider making web image search default to thumbnails.
Okay.
I don't know what other people think, but every time I use it, I end up using thumbnails.
Yeah, I do the same thing.
I mean, it's a little weird to have it. Yeah. I don't know what other people think about this. I agree that these could be de-experimentalized. Unless the only thing about screen image is this question about which screen you're talking about. But I guess we're okay with that. I guess that works okay. This needs more discussion. Wow, you don't want to de-experimentalize external evaluate. Okay. All right, listen, I need to go here. We've got more to figure out. I think we caught some useful things here. A lot of work, a lot of work. Okay, any last comments from anybody? Nope. Okay.
Bye-bye.
Thanks everybody here. Thanks to folks on the live stream. Appreciate it. See you later.